Okay, Eureka Math, Grade 4, Module 3, Lesson 38. This is our last lesson in this module. Tomorrow will be your assessment for end of module. Learning target, I can multiply two-digit numbers. I can multiply learning criteria, I can multiply two-digit numbers using an area model, and I can relate the area model to the standard algorithm. Application problem. Sandy's garden has 42 in each row, 42 plants in each row. She has 2 rows of yellow corn and 20 rows of white corn. Draw an area model representing 2 partial products to show how much yellow corn and white corn has been planted in the garden. This application problem will be related to our first problem in the lesson. Please pause the video for about 4 minutes to complete this problem, and then the next slide will have the solution. So Sandy's garden has 42 plants in each row. I'm going to draw an area model representing 2 partial products. So the numbers involved, 42 plants. We have 2 rows of corn and 20 rows of white corn, 2 rows of yellow corn. So two rows of yellow corn would be 2 times 42, which equals 84. 2 times 2 is 4. 2 times 4 is 8. And then we would multiply 20 times 42. So she had 84 yellow corn plants and 840 white corn plants. So we're going to connect what we just did to the standard algorithm. So the first thing we would multiply would be 2 times 42. So 2 times, we start in the ones place. 2 times 2 is 4. And put the 4 down underneath of the ones place. And then we would multiply 2 times the tens place, which is 40. 2 times 4 is 8. So we have 84. And that's the same as we got there. And then we would multiply 20 times 42. We could put down our 0 right away because that 20 that we're multiplied is a multiple of 10. So we know we could put the 0 right off at the beginning. Then we'll multiply 2 in the tens place by 2 in the ones place, and that would be 4. And then we'll multiply the 2 in the tens and the 4 in the tens, and that would be 8. And we can see that that is the same as what we got in our area model. Go back. So now we want to know how much altogether. So now we add those two together. So 4, there are 2 partials together. 4 plus 0 is 4. 8 plus 4 is 12. Put down our 2, carry our 1. 1 plus 8 is 9. So 924. Okay, so we're going to solve this starting with the standard algorithm. We're going to multiply 62 times 29. So as an area model, we have, this should say 60 right there. 60 plus 2 times 20 plus 9. Now, we put the 9 at the top and not the 20 first, because if we do, it would be flipped compared to the standard algorithm. So we don't put the 20 here. No, we put the 20 at the bottom so that because we're multiplying the tens place second. So we want to put the ones place first and then the tens place. Okay. So we'll multiply first 9 times 62. So we'll start with 9 times 2, which is 18. So we're going to start here at 9 times 2, which equals 18. We're going to carry our 1 and put down our 8. Next, we multiply 9 times the tens place, which is a 6. 9 times 6 is 54, plus 1 more, 55. So here we can multiply 9 times 60. 9 times 6 is 54. And this is a power of 10, a multiple of 10, so we put down our 0. If we add these two together, this, we will have 8 plus 0 is 8. 1 plus 4 is 5. 558. That matches right there. Now we're going to multiply, change my color, our tens place. So we're going to multiply 20 times 62. Now we're multiplying the tens place, and that is the same thing as 20, which is a multiple of 10. So we could put our 0 down for the 10 right away for multiplying by 10. So put the 0 right there. Now we're going to multiply the tens place by the ones place, which is 2 times 2 is 4. And then we're going to multiply 2 times 6, the tens place by tens place. 2 times 6 is 12. Plus, oh, did we do the plus? Yeah, we did up there. That one's already been done. You could cross it off so you don't get confused like I almost did. So 4, 6 times 2 is 12. And we will add those two rows together. So let's go over to our area model. We have 20 times 2. Well, if I have two 20s, I know I have 40. 2 times 2 is 4, and 1 0, 40. And then I have 20 times 60. I have 2 zeros that I'm ignoring. 1, 2, and 6 times 2 is 12. I'm not really ignoring them. What I mean by when I say ignore them, you're ignoring them for a moment, but what you're really doing is realizing that those are tens, and I could just add those zeros in. I could just add those zeros in and not worry about multiplying them all the way out. They're just going to add, because every time we multiply by a place of 10, we're moving over one place value and we filled that in with a 0. So in 20 times 60, we're multiplying 10 times 10. And so we're going to move that place value over 2 times before we deal with our non-zero numbers there, our non-tens. So now we add these together and we have 1,240. And we add, and we can see that these came out to be the same also. And we add them together, they will come out to be the exact same number, and it matches. Okay, one more problem before doing the problem set. 63 times 46. 63 times 46. So the first thing we're going to start out with is the 6. And again, 60, forgot the 0 there, 60. Okay. So 6 times 63. And then 40 times 63. Because that matches here. And that matches what would be here, 63, 6 plus 3, 60. 6 times 3 is 18. We'll carry our 1. 6 times 6 is 36 plus 1 more is 37. Now I'm going to do my second row. 4, 40 times 63. Well, that's a 40, so I'm going to put my 0 in right away. 4 times 3 is 12. Put down my 2, carry my 1. 4 times 6 is 24, plus 1 more is 25. Add. Now let's compare it to the area model. We have 6 times 60. So 6 times 6 is 36. And then times 10. 6 times 3 is 18. If we add those together, we have 378. 40 times 3 is 120. 4 times 3 is 12. Times 10, 120. 6 times 4 is 24. 6 times 4 is 24. And we have times 10, put in 2 zeros. Add those together, we have 2,520. And that's the same. If we add these, since they're the same numbers, they're also going to equal 2,898. Okay, head over to Seesaw.